Well, thank you for singing that song so well. And you see the title of our lesson this evening, Origins. Is it reasonable to believe in God in this scientific age? I can tell you the answer to that question on the part of many folks, particularly in the scientific community, would be absolutely not. Because the more we learn about the natural world, the less reasonable it is to believe in some kind of a God. Because the more we learn, the more we understand how the world and all that's in it came about by natural causes, there is no necessity to posit the existence of God. Our title for this series is Christians Facing a Corrupting Culture. This lesson fits perfectly with that series because this is one of the challenges we're facing in this modern age. And that is more and more people are taking the position that God is unnecessary because of all we're learning through science. The song you just sang was written by A.W. Dicus. Many of you probably don't know that A.W. Dicus was the academic dean at Florida College when I was a student. That was before the flood. So my kids say, anyway. And so it's a pretty special song to me since I was in school back in the 60s at that school. And later in the 90s and 2000s, I was privileged to literally sit in his seat, having served as academic dean for 18 years at that same school. Brother Dicus wrote that song in 1966, and I'm convinced that he did it because that was the peak of the God is Dead movement in the United States, as illustrated by this Time magazine article. The headline on that magazine, April the 8th, 1966, was, "Is God Dead?" Now, I asked last night, some of you were alive that year, right? Shake your head and make me feel better. And I don't know if you remember, there was a big splash about the God is Dead movement in America. And it is right during the middle of that A.W. Dicus, a physicist and widely respected scientist, wrote the song that you just sang. Our God, He is alive, not dead. But here are some of the things that were said in those days. Thomas J.J. Altizer and William Hamilton wrote a book called Radical Theology and the Death of God. By the way, they're both theologians, supposed Bible believers. And here's what they wrote. We must realize that the death of God is an historical event, that God has died in our cosmos, in our history. And the dead God is the God of the historic Christian church, and beyond the church of Christendom at large. So the God that died, folks, is the God of Christendom. And of course, if that God died, that means we created Him in the first place, right? So what was being commonly propounded in the 1960s by theologians is that the God we thought existed has died. We don't need Him anymore. So here we are in the 2018 year, many years later, and I can tell you that notion that God is not needed is still widely propounded. So is it reasonable to believe in God in this scientific age? Let's turn to Psalm chapter 8. O Lord, our Lord, how excellent is your name in all the earth, you who set your glory above the heavens. Out of the mouths of babes and infants you have ordained strength because of your enemies, that you may silence the enemy and the avenger. When I consider your heavens, the work of your fingers, the moon and the stars which you have ordained, what is man that you are mindful of him, or the son of man that you visit him? For you have made him a little lower than the angels, You have crowned him with glory and honor. You have made him to have dominion over the works of your hands. You've put all things under his feet, all sheep and oxen, even the beasts of the field, the birds of the air, and the fish of the sea that pass through the paths of the seas. O Lord, our Lord, how excellent is your name in all the earth. One of the many psalms in the Old Testament that proclaims that the natural world is a testimony to the existence of God. And certainly in the ancient days, most people believed, from looking at the natural world, there has to be a God behind this. Turn next to Romans chapter 1. The New Testament passage that I think is the strongest testimony that the natural world gives us evidence for the existence of God. Romans 1 verse 20 says, "For since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." So what is that passage saying to us? It is saying you can examine the natural world, look at things that clearly have all the evidence that they were made, and therefore they testify to a grand and glorious Maker, whom the Bible calls God. It's the famous argument from design. Always, in my opinion, the strongest of the arguments from the natural world for the existence of God. So is it reasonable to believe in God in this scientific age? I would like to say to you at the beginning tonight, in my judgment, it's more reasonable than ever. And we have less excuse than ever for missing that there is a God. So I appreciate your singing so enthusiastically a while ago. Our God is alive. In Him we live and we survive. I believe you can learn that without this book. And this book itself says the evidence of the natural world is sufficient to have you believe that there is a God. So please forgive me if anybody takes offense that for the rest of our time this evening, I'm not going to use this book. I'm going to use God's other book. You see, He also wrote the book of the natural world. And it is to that to which I wish to appeal for the rest of our time this evening. I'm a believer that the Bible is the Word of God. But folks, when you examine the natural world using the sciences, it's inappropriate to quote the Bible, because that's not the way science works. Science examines the features of the natural world and tries to come to conclusions based on how the natural world functions. And I'm here to tell you tonight, I'm convinced there's sufficient evidence in the natural world, as Romans 1:20 says, that you're without excuse for missing that there's a God. The evidence is powerful. So I want to share some with you tonight. And this is a subject that ought to go on for weeks. So once again, I ask your indulgence as we touch the veritable hem of the garment this evening. And if you're a science math person, young people and even older folks, I hope I tease you into digging more deeply than we're able to do tonight. So thank you for being here. And now let's get at it. Are you ready for a science lesson? If you're not aware, I'm an old science teacher. I taught chemistry for many years. I have advanced degrees in chemistry and mathematics. I've been studying this topic for a long time. And I love teaching science. So if you don't like it, get over it. If you don't like it, it's because you didn't have me as a teacher. We start with this amazing picture. because my subject tonight is design at the macroscopic level. The subtitle is The Rare Earth, and you'll understand that in a moment. But first, let's look at this picture. You recognize that picture? Some of you were alive when that picture was made. It's probably the most famous picture ever made. And just as a little sidelight thrown in free of charge, I have the original printed copy of that picture hanging in my office. If you're interested in finding out how I got it, just ask me later. That picture has a name. It's called Earthrise, because that's Earth seen from the moon for the first time in human history. So I'm going to read you from a book that I highly recommend called The Privileged Planet. On Christmas Eve, 1968, the Apollo 8 astronauts, Frank Borman, James Lovell, and William Anders, became the first human beings to see the far side of the moon. 1968. Raise your hand if you were alive. Okay? The moment was as historic as it was perilous. They had been wrested from Earth's gravity and hurled into space by the massive, barely tested Saturn V rocket. You remember, you that were alive? Although one of their primary tasks was to take pictures of the moon in search of future landing sites, the first lunar landing would take place just 7 months later in 1969. Many associate this mission with a different photograph, commonly known as Earthrise. And there it is. Emerging from the moon's far side during their fourth orbit, the astronauts were suddenly transfixed by the vision of Earth, a delicate, gleaming swirl of blue and white, contrasting with the monochromatic, barren lunar horizon. This is the lunar horizon over here. Earth had never appeared so small to human eyes, and yet was never more the center of attention. To mark the event's significance and its occurrence on Christmas Eve, the crew had decided, after much deliberation, to read the following. In the beginning, God created the heavens and the earth. The reading and the reverent silence that followed went out over a live telecast to an estimated 1 billion viewers, the largest single audience in television history. May I just ask, do you think in 2018 they'd be allowed to read that passage from space? It's politically incorrect now. But I'm thankful that in 1968, our astronauts read that from outer space. And I will tell you that Frank Borman and James Lovell became stronger believers in God because of this experience. On the other hand, William Anders, who was in the same spaceship and saw the same things, became a greater disbeliever. He would say later, I saw no evidence of God up there. Look at that little blue spot in the midst of all this nothingness. You seriously think there's some God that cares anything about that? It illustrates a point, doesn't it? The same evidence can bring people to completely different conclusions, depending on their presuppositions. And may I say, every one of you sitting in this audience has your own set of presuppositions. And one of the challenges in the sciences is for you to try to step back and take a look at things without presuppositions. That's impossible. Nobody can do that. But I would ask you tonight, if you're listening to this, if you're here this evening and you have doubts about the existence of God, would you at least give yourself the chance to step back and say, maybe there's something I haven't seen properly, and give God a chance? Because there's abundant reasons, in my view, for you to believe that there's a God, even in this scientific age. Well, here's another famous voyage. Voyager 1 spacecraft took off in the late 1980s. And there's its path. Let's see if I can point this out to you. Here it is on Earth. Boy, this thing's hard to hold still. Here's Earth, and it takes off, and it passes through all these planetary orbits. Here's the orbit of Pluto, by the way, that we talked about Sunday. And it went on past it, Voyager 1. The object of Voyager 1 was to just send this object out into space and let it just keep going and keep sending pictures back as far as it could go. Now, are we able to dim the lights in here, folks? I forgot to ask you ahead of time. Can I have a couple of light guys? And when I ask you in a moment, I want you to dim the lights for me. Because some of these things you can't see as well with all this light. Just wait now. Now he's messing with me. Voyager 1 spacecraft in 1990, from some 4 billion miles away, took another picture. I'm going to show you that picture. So now we want the lights off. All of them off. Not those, I don't want those over there. Thank you. Could you all hang around there for just a minute? Because I don't want everybody falling asleep out here. See that little blue dot right there? The arrow is not in the picture, folks. That was added later to point out the blue dot. Because of the reflection of sunlight, Earth seems to be sitting in a beam of light as if there were some special significance to this little small world. This is coming from a book called The Pale Blue Dot by Carl Sagan. But it's just an accident of geometry and optics. You see that beam up there? That's just an accident that this blue dot happens to be sitting in that beam. And here's Sagan's observation. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe are challenged by this point of pale blue light. Our planet is a lonely speck in the great enveloping dark. In our obscurity, in all this vastness, there is no hint that help will come from somewhere else to save us from ourselves. Now turn the lights back on. Are you depressed enough? Carl Sagan would say to you, ladies and gentlemen, and pardon me if I call you class every now and then, because this is a class. You folks in this audience who believe in God better get over it. Because the more we learn about the natural world, the less evident it is that there is some kind of a God. Think about it. You think there's some God that cares about that? We're an insignificant dot in the midst of vast cosmic dark. And God believers are fading out. Well, you probably know Carl Sagan has passed from this life. My view is I have an idea he knows different now. But does this necessarily speak against the existence of God? He and William Anders certainly thought so, and a lot of others. When I was in school at Harvard, we had several required readings. One of them was Intelligent Life in the Universe by Shklovsky and Sagan. It's a book full of conjecture. But I will tell you what the conjecture was in those days in the 1960s. It was that the likelihood that there are other civilizations like ours are probably far more advanced in the Milky Way galaxy is so high that it's almost one. And that there are very likely thousands of civilizations more advanced than ours because evolution has taken place lots of times in lots of places by natural causes. And so in this book are several lines of reasoning by which we might discover that there are such civilizations. And folks, I was listening last night on the way home from church services to 5:40 a.m. and they were discussing UFOs and little green men and things that people have seen. Here we are in 2018. There are lots of people that believe this earth has been visited by aliens from outer space. This is not something that a lot of folks don't buy into. And in this book, written by two of the experts, Shklovsky and Carl Sagan, the same one we just read from, took the position that surely there are lots of other civilizations in the universe. And one of the things they quote is Frank Drake's famous equation. This is supposed to be a way to estimate how many there are in the Milky Way galaxy. And while I don't have time to go through all of this, just look at this. This is the number of communicating civilizations in our galaxy right now. Boy, I don't like this thing. That's N. NS is the number of stars in our galaxies, which is about 2 times 10 to the 11th. That's a lot. 200 billion. FS is the fraction of those stars with suitable for life. Well, how do we know that one? Folks, that's a guess, as are all the rest of these. So he estimates that, and then he keeps a fraction of suitable stars with planets, average number of habitable planets, the fraction of which life develops. Wonder who knows that. The fraction on which intelligence develops, the fraction which try to communicate, and the fraction of the star's life during which communicating civilizations last. And at the bottom down here, which you can't see very well, his estimate for N is somewhere between 0.0000005 and 750,000. Now that's nailing it down. But that's about the best they could do, and Frank Drake's equation was really widely accepted as a good start to answer this question. The fact is, Carl Sagan and I.S. Shklovsky firmly believed there were thousands in our own Milky Way galaxy. That was in the 1960s. Now, folks, here we come along to 2004, and I want to introduce you to another interesting book called Rare Earth by Peter Ward and Donald Brownlee. They are thoroughgoing evolutionists, ladies and gentlemen. Don't want to misrepresent them. They absolutely believe life evolved by natural causes here or wherever. But the position taken in this book, why complex life is uncommon in the universe, is based on a lot of science. You see, we've learned a whole lot more about life at the scientific level, at the cellular level in the last 50 to 60 years than we ever knew in all lifetime of mankind before that. And what we're learning is life is so complex, way far more complex than we ever dreamed in 1960, that the chances of it existing somewhere else in complex form is rare. In fact, these two gentlemen who are evolutionists hint that maybe they're in another place in the whole universe like this. To write this book in the 1960s would have been heresy in the scientific community. But here we are 60 years later, and they're openly saying, this earth and its complex life is rare, folks. That's not me talking. But that's one of a number of books like that, and I'd highly recommend. The Privileged Planet is another one, which I've quoted from just a while ago, by Guillermo Gonzalez and Jay Richards. And by the way, when this came out in 2004, you see, Guillermo Gonzalez is an astronomer at Iowa State. He had about 160 professors rise up in holy horror that he would dare to suggest the Earth might be a privileged planet and it might have been designed by somebody. The very idea that an astronomer would suggest such a thing was beyond imagination. And I will tell you, the man never got tenure. And I doubt he ever will. Because he dared to suggest that there might be a creator. How our place in the universe is designed for discovery. They take the position that our universe, and particularly our place in it, looks like it was designed so we'd have the absolute best possibility of examining our universe, and the same features that allow that allow life to exist. And the question is that a coincidence? And their suggestion at the end of their book is, no, it doesn't look like a coincidence. Looks like it was designed. The very same rare properties that allow for our existence also provide the best overall setting to make discoveries about the world around us. So it looks like we are a privileged planet after all, in a host of ways. But there's a third book I'd like to spend a little extra time on this evening because it's written more for the common reader, not the scientist. And it's called God's Crime Scene by J. Warner Wallace. You might be interested in knowing that J. Warner Wallace is a cold crime detective. He was raised by parents who were atheists all of his life. His father and mother are still atheists. He wrote this book having become a believer in God in hopes that he might impact his own father. And he calls it God's Crime Scene. And here's what he says. It's a cold case detective examining the evidence for divinely created universe. So how would a cold case detective go after the universe, whether it's designed or not? Well, he said, let's use the same techniques we use as detectives, and let's examine it. So if you will bear with me for the next few minutes, I want to explore his approach to examining the universe to see, is it reasonable to believe that this universe was designed? Somebody was tinkering with this. Didn't just happen to be the way it is. Somebody was tinkering with this. That's his position. So he quotes from several sources. Here's a little book called The Goldilocks Enigma. Why is the universe just right for life? Now, children, you all remember the story of Goldilocks, don't you? I wish I could have one of you tell it. Goldilocks. Remember she went out into the forest and found the home of the three bears? And she went inside, and there were 3 bowls of porridge. So she tasted the one, it was too hot. She tasted Mama Bear's porridge, it was too cold. But Baby Bear's porridge was just right. And she ate it all up. Remember? And that story went on that way. Well, the Goldilocks enigma is this. Why does the universe look like it's just right for living things? In particular, us. Why does it look like that? And may I say to you, class, this is not an element for disagreement among scientists. Even those who don't believe in God admit this. Here's one quote. One of the most significant facts, arguably the most significant fact about the universe, is that we're in it. We're part of it. How'd we get here? Everyone agrees that the universe looks as if it was designed for life. It looks as if our universe is spectacularly fine-tuned for life. By this I mean only, be careful here, that it looks as if small changes in this universe's basic features would have made life's evolution impossible. So clearly all these folks are evolutionists, but they certainly are having a struggle with why does it look like everything was designed so we could be here? That's a problem. It's called the anthropic principle. Anthropos is the Greek word for human beings. And it has been well established by the scientists that there are an awful lot of features about the universe that look like they're made just for us. In the 1960s, scientists had discovered two characteristics of the cosmos that were fine-tuned to make physical life possible, and 8 to 10 characteristics of the solar system that were fine-tuned in the 1960s. So maybe these guys could be forgiven for thinking evolved life is just as common everywhere. But what's happened is, since then, by the 2000s, scientists had discovered 38 characteristics of the cosmos and over 150 characteristics of our solar system that are all fine-tuned for life, ladies and gentlemen. So here's my question to you, ladies and gentlemen of the jury, and you're going to have to be your own jury about this. You're going to have to decide for yourself. How many coincidences does it take to convince you this isn't a coincidence? And what I'm telling you is by the 2000s, we've now discovered over 188 different features of the universe that all look like they're designed for us. How many times are you going to say, well, isn't it interesting how all that just kind of fell together? It had to happen somewhere, and it just happened to happen here by natural causes. That's really the question you have to answer. And I can't answer that for you. But I'll tell you, for me in my house, it gets to be ludicrous to some point. So what I'd like to do with you is talk with you about some of those features that are fine-tuned. And by the way, we don't allow telephones either. If you were at Rotary, we'd fine you $10 for that. All right. And the reason for that, it gets distracting. Let's see. Let me take my thing here with me, because I want to come down here closer to you. I'm going to read you a little bit from this cold case detective book called God's Crime Scene. Every chapter in this book, ladies and gentlemen, is written in such a way that it's built around one of the scenes that one of the crime scenes that he actually, as a detective, solved. Okay? You ready? Helen knew something was wrong when her daughter Carrie failed to answer the door. It was a bright summer afternoon. Carrie said she'd be home, and her car indeed was parked in the driveway. Helen tried to peek in through the living room window, but the curtains were unusually drawn. Carrie never locked the back door. But when Helen walked into the backyard of the old house, she found the door locked and all the windows closed. This was not like Carrie. She usually left one badly worn rear window slightly ajar. Helen began to panic. She knew Todd and Carrie had a tumultuous marriage, one that included physical violence. Todd had moved out, but Helen still feared for her daughter's safety. The couple had a child named Lexi, but the violence had only intensified since her birth. A week ago, Todd had threatened to kill Carrie. And just last night, Carrie confided there'd been another fight. When Helen couldn't get Carrie to answer the door this afternoon, she decided to call the police. Now, I'm going to skip a little bit here. The police came. They couldn't get the door open, and when they did, they discovered there was this odor of gas in the house. So they called the hazmat team, who came and put on their mask and went in and did what they needed to do, and found all kinds of incriminating evidence, like old clothes stuffed under the door upstairs, and the gas on, and lots of other things. And so, eventually, they were able to get into the bedroom upstairs, and they found Carrie and Lexi dead. So the question was, did this come about by natural causes, things that happened just because people were careless or whatever other set of events? Or was there some external tampering that brought about these two deaths? That's the question. And so the detective set about to figuring out the details. So let me share with you some of the things he said. When we look at nature of the universe, the evidence we must answer is, why are there living bodies? Not dead bodies, living bodies. And lots of them. And that ought to provoke a similar kind of investigation. We need to answer, why are there living bodies? Like they needed to answer, why are there two dead bodies here? Like our murder scene, there are foundational, regional, and locational conditions demanding explanation. The foundational laws of physics, the regional properties of our solar system, and the locational conditions of our planet resulted in our existence. But did this have to be the case? If circumstances had been just slightly different in Carrie's house, no one would have died that night. The conditions had to be just so for the outcome to be death. In a similar way, if circumstances had been just slightly different in our universe, there would be no life today. Conditions had to be just so, or there'd be no life. That's the argument. Then he proceeds, as a detective, to investigate the foundational, regional, and locational evidence in the universe. And that's what I want to share with you for a few minutes. Now, folks, it gets a little heavy, and you're not allowed to fall asleep. So if you start falling asleep, I'm going to make you stand up. Because what I'm about to tell you is the heavy work to undergird evidence that life is here because it was designed. Too many coincidences, folks. And by the way, Todd was convicted of first-degree murder based on the series of circumstantial evidences that added up. You can be convicted that life came about by design by looking at the evidence. That's the point. All right. Every chapter is a story like that. You want to read this book. It gets a little heavy sometimes, but it's all right. So, let's just talk about a few things. By the way, I need to back up. Can I do that down here? Yeah. How about foundational factors? Things that are background. In the case of Carrie's death, that was things like the family was a mess. There are a lot of things surrounding this case. I mean, they just had a fight last night. He had threatened to kill her. There's a lot of background that would lead you to think this was a murder, not some natural thing that happened. All right, in the universe, there are lots of foundational fine-tuned factors that support life that have to be just right. For example, the strong nuclear force, and I know you're thrilled about that. The weak nuclear force, the electromagnetic force, the gravitational force, the ratio of electrons to protons, the mass density of the universe, all of those factors, if you change those factors by one teensy little bit, there would be no life. Period. And nobody argues with this, folks. This is well known. So to illustrate one of these, if I may, I want to quote here from this same book. The ratio of electrons to protons must be precariously balanced. If the value of this ratio deviated by more than 1 in 10 to the 37th, the universe as we know it would not exist. You listening? If the ratio between the electromagnetic force and the gravitational force was altered by more than 1 in 10 to the 40th, this universe would suffer a similar fate. In other words, you change those quantities by one teensy bit. How teensy is it? Let's see if I can illustrate that. He tries to get you to see how teensy that is. So don't you go to sleep. Listen closely. Imagine covering the entire North American continent in dimes and stacking them till they reach the moon. You with me? The whole North American continent stacked in dimes to the moon. Now imagine stacking just that many dimes again on another 1 billion continents of the same size. If you marked one of those dimes and hid it in the billions of piles of dimes, the odds of a blindfolded friend picking out the correct dime would be approximately 1 in 10 to the 37th. The same level of precision required in the strong nuclear force and in the ratio of protons to electrons. Would you say that's teensy? So I'm telling you, folks, these factors I've listed, 2, 4, 6, there are 38 of those that are all the same way. You change it one little teensy bit and you wouldn't be here. Okay, well, it had to happen somehow. I mean, it's just chance happenings, random happenings will bring about amazing things over long periods of time. Okay? You want to believe that? Let's go on. What about regional fine-tuned factors? What about our solar system? Folks, to support life, it can't just be anywhere in the universe. You have to have the proper type of a galaxy to support living systems. Well, we've learned that there are lots of types of galaxies, and we've learned more since the Hubble telescope. And if you have not been to the internet and looked at Hubble pictures, you've got to do that. It's incredible what this device, which gone outside of our atmosphere, taking pictures, has done for us in terms of opening up whole new worlds. And so, guys with the lights, could I get you to help me one more time? Because it's so much more dramatic when it's dark. You live in Orlando, you have not seen the sky at night. You need to go out west in the desert and then look up. So here's a picture from Hubble telescope. Go ahead and get them all off. That's a portion of the constellation Serpens. Just one tiny portion of our sky, the universe. Well, you say, look at all those, whoops, what happened? Why is it doing that? I thought this was the pointer. Is the pointer top or down? Oh, okay, that's why it's doing it. All right. You see that right there? You say, look at that star and that star and that star and that star and that star. Look at all those stars. Look, folks, that thing right there is not a star. That's a galaxy that has 200 billion stars in it. As there are lots of others of those in that picture. Many of those blobs of light are galaxies. And I'm only saying that to tell you the massive number of galaxies in the universe. That's why Sagan would say, you sincerely don't believe that there's life forms lots of places? There's so many galaxies out there. Surely life evolved somewhere else. Okay, you can turn the lights back on now. Thank you. There's some problems with that position. Most of our galaxies out there are elliptical, like this one. And scientists would tell you that elliptical galaxies do not support planetary systems like our Earth surrounding the sun. There's too many forces working against it. So most of the galaxies in the universe would not support life as we know it. There are irregular galaxies that certainly wouldn't work. There are spiral galaxies. There's also other kinds of galaxies that blow up every so often that certainly wouldn't be good. Seyfert galaxies. But spiral galaxies are just right. Guess what kind of galaxy we live in? A spiral galaxy. And of course, an evolutionist would say, well, that's just the one where it allowed it to happen. So that's just another one of those coincidences. But it is a fact, ladies and gentlemen, that most of the galaxies in the universe would not support a planetary system with life on it like we have. Okay? So most of those stars out there are eliminated. And everybody knows it. But it doesn't just take the proper type of galaxy, it takes the proper place in the galaxy. So here's a picture of our galaxy on its side. It's a spiral galaxy, and here's this bulge in the middle. Guess where life could be supported inside this whole galaxy? There's a little blob right out here. Come on. Where'd it go? All right. And there's two little blobs out on each end that will support planetary systems like ours, even in a spiral galaxy. So all the 200 and some odd billion stars in that galaxy, most of them are eliminated. If you're too close to this blob in the middle, the gravitational force is so big, it'd be whoosh! There'd be no planets. So most of the stars in spiral galaxies are eliminated. You have to be in a certain very narrow region to support life. That's not all. You have to have the proper kind of star. Our sun is a pretty special star. But let me show you some things about it. Here's our sun compared to the planets. I mean, if you look at relative scale, here's the sun and here's Jupiter, the largest planet in our system. Well, the sun's a whole lot bigger, right? But let me show you our sun compared to some other objects. Here's our sun compared to Sirius, the dog star, and Pollux and Arcturus. There's the sun, right there. And there's Arcturus! Much larger. But that's nothing. Watch. Can you find the sun on there? Here it is. It's one little pixel right down there. Compared to Antares. Here's Arcturus. There's Antares. Folks, our sun is an average-sized star. There's lots of stars smaller. They're called dwarfs. And there's lots of stars way bigger. And our sun is just right. Exactly right. Happens to be almost exactly in the middle of the spectrum. It's just right. You think there could be planetary systems around Arcturus? Are you kidding me? They would survive about 1 millisecond. It also takes the proper mass of planet. What do you think about Jupiter for supporting life? Not a chance. Saturn, Uranus, Neptune, no way. There are all kinds of features about those planets. First, they're too big. So in our planetary system, you know how many there are that we would put in the habitable position? Earth, Venus, and Mars. All in the proximate range. Nobody's looking for life on Venus. Maybe you don't know why. The atmosphere on Venus is mostly sulfuric acid. This is a problem. Mars is where everybody's looking, right? And that's where the next space probe is supposed to go because it's the closest in its features relative to Earth. But folks, it's been tough to even find good solid evidence for water, which we'll come back to in a minute. But let me tell you again, just any old planet will not do. It has to be a planet with the proper mass or it'll never work. And that's within a very narrow range, ladies and gentlemen. So there's another one of those coincidences. Not only that, it has to have the right spin. And it has to be the right distance from the sun. And it has to have the right tilt. Am I skipping a bunch of stuff? Each one of those deserves a lesson. Of all the planets in our planetary system, how about Mercury? It's too close, which means it's too hot. How about Pluto, folks? Too far away, it's too cold. But in the habitable zone is, guess what? Earth. And Mars kind of out here on the edge. You've eliminated all the other planets. It has to have the right spin. I wish I could talk to you about that. Our Earth spins at a rate of roughly 1 time every 24 hours, right? You need to go home and get on your knees and thank God for that. You wouldn't be here if it didn't. And the right tilt. Look, you learned this in junior high, didn't you? What does the Earth's tilt do for us? It gives us our seasons. It gives us proper distribution of heat. It gives us all kinds of fascinating things that are all critical for life. You also have to have the right moon. Look, it's not just for lovers to sit there and go, oh. Our moon does all kinds of things for us, and we only have how many? I told you Sunday night or Sunday morning, Pluto has 5. Our moon does all kinds of fascinating things for us and allows life to survive. Atmospheric conditions, terrestrial crust, and 140 more that each deserve a full lecture tonight. So I say to you again, ladies and gentlemen of the jury, I'm now telling you, don't believe me. You go look for yourself. There are 150 different features of our solar system. These are regional factors that all point to design or pure coincidence. How much of that can you stand? Before you're convinced, somebody tinkered with this. This didn't just happen. And then there's water. You see, I'm an old chemistry teacher. So you got to get back to chemistry at some point. And water is the most amazing substance in this universe. and everybody knows you have no life with no water. Our earth is covered more than 70% with water. And they're up there scrambling around on Mars trying to find a little tiny evidence that there was water up there sometime, somewhere, in some kind of an amount. We're covered up with it. Most plants and animals contain more than 60% water by volume. So when your brother calls you a waterhead, he's right. Watermelon is 98% water. Sure is good though, isn't it? Water, you see, has a unique structure, H2O. But what you don't know if you didn't study chemistry is that the bond angle between the two hydrogen atoms and the oxygen atom is 104.5 degrees. And were that not the case, it would not have the polar features that it has. It has a negative end and a positive end, which makes it have the features unique in all of the universe. It's an incredible substance. It's the only substance on earth that exists in all three states, solid, liquid, and gas. It has a uniquely high specific heat. It takes a lot of heat to raise the temperature and to lower the temperature of water, and you better be thankful because you're 60% water. It regulates your temperature. You want to stay approximately the same temperature, folks? Come to St. Pete, Florida. It's surrounded on three sides by water, and it hardly ever gets above 90, hardly ever gets below 60. It's hard to change the temperature of water. It's unique. If you were in my chemistry class, we'd spend 6 weeks on water. It's still the most studied substance in the universe. You'd think by now we know everything there is to know about water. No, we don't. But I'll tell you one thing we do know. If you look at other things in the universe and you look at their features like specific heat, here's everybody else and boom, there's water. Or here's everybody else and boom, there's water. It's unique. So you can believe if you wish, that just happened, and it just happens to be the most important substance for life. And we happen to have gobs of it on this earth. Or you can believe, looks like there was design behind that. Temperature range for the liquid is 0 to 100. You better be thankful. Less dense as a solid. Can I take just a minute on that, people? Did you drink tea tonight? I drank ice water. And where was the ice? At the top. People, that's the exact opposite of what should happen. Solids are more dense than liquids, aren't they? Which means they should sink. In the case of water, when water freezes, it expands, so it's less dense than the liquid, which makes it float. Of all the substances in the universe, there are very few that do that, and water's one of them, and it's the most abundant in many respects. Okay, that just happened too, right? And you do know, don't you, that if that weren't the case, there'd be no life on earth. It's a universal solvent. It has high surface tension and cohesion and adhesion. How do you think water gets from the roots of a tree 70 feet up in the air? Because of these properties of water. You go home and try, get a capillary tube, a little tiny capillary tube, and stick it down in a glass of water and watch the water rise in it without you doing anything. Everywhere we look, ladies and gentlemen, from the foundational to the regional to the locational, it sure looks like things are fine-tuned for life, and it looks like somebody did it. So why isn't it more reasonable to believe that somebody did it than not? I say with Michael Behe and his wonderful book, Darwin's Black Box, which, by the way, has a 10-year update. Get the later version because he argues that it gets worse for evolutionists the more we learn. there's a loud, clear, piercing cry of design. And by the way, he wrote it in all caps with exclamation points so I can yell. Everywhere you look, from the macroscopic to the microscopic, things sure look like they're designed. And I say to you, it's abundantly reasonable to believe that they were designed by a magnificent intelligence whom we call God. Which is why I have no problem singing with great vociferousness, our God is alive. In Him we live and we survive. And that's our lesson for tonight. I thank you so much for your careful attention. I hope if you're doubting the existence of God, we've opened up at least enough of a door to say to you, would you consider examining the evidence of the natural world? In my mind, it's very useless to start quoting this book to an atheist. He doesn't even believe God exists. Why would you quote the Bible to him? But if a person can come to believe that there's a God, then maybe the next step is, well, do you think that God may have tried to communicate with us some other way besides the natural world? And the answer is amen. He has. And so I conclude tonight, as we do every lesson of this sort in a public fashion like this, by saying to you, there are reasons to believe. And God has given us abundant reasons to believe in Him in more ways than that. The greatest of which is Jesus Christ, our Lord, who said in John 14, if you believe in God, believe also in me. And He went on to say, in my Father's house are many mansions. I go to prepare a place for you. And if I go, I will come again and receive you to myself, that where I am, there you may be also. You see, the message of the Bible is that God so loved the world that He gave His only begotten Son, that whoever believes in Him will not perish, but have everlasting life. And Jesus said, I am the way, the truth, and the life. No man comes to the Father but by me. So if you're here tonight and you've become a believer in Jesus, then what He calls on you to do is follow Him all the rest of your life. And you start that by submitting to His will and saying, it'll no longer be my will, but yours that is done. And I believe with all my heart you're the Son of God. If you were to say that tonight, we'd stop everything and immerse you in water for the forgiveness of your sins, because that's what Jesus said to do. And then you could rise to walk a life of devotion to Him. So if you're ready to do that tonight, won't you come while we stand and as we sing.